My name is Dr. Rob Ward, and I want to welcome you to another class in the video series about the redox connection with various health elements in our lives. Today's topic is athletic endurance and the redox roots of our athletic endurance. So there are a lot of people who care deeply about maintaining a healthy posture as they exercise. And one of the greatest ways to do that is to maintain your redox potential as you go about exercise. So let's spend a few minutes talking about our muscles and how they work and their physiology. So our muscles are referred to as skeletal muscles. That's the muscles in our arms and legs and backs and so forth. And they have certain characteristics. They have the same cellular components as other parts of our body, but because they are muscles, their sole job is to contract, and as they do, certain muscle cells will slide across each other. This is made possible through the movement of ions, calcium ions, and other elements, and as they do, the muscle cells contract. So these muscles are sort of long, but for the purposes of our discussion, I've just kind of drawn it like a circle. So every muscle cell has multiple mitochondria. Their job is to produce energy from food. The cell has a cell membrane, which is critical in helping it maintain its balance of nutrients in and oxygen in and carbon dioxide out and waste products out. The nucleus is in charge of directing the repair and replacement properties of that cell. So when we exercise, we're asking our muscles to conduct a certain activity. And as we propel them forward and ask them to do more than they're just basically capable of, there's a remodeling process that takes place. And it has been discovered not that long ago that reactive oxygen species, reactive molecules, redox molecules, are involved in the remodeling process and adaptation of our muscles. So athletic endurance requires muscle cells to be able to adapt to our demands and requests. And as we get stronger, we build new cells, they adapt and become a little more tough, more capable of moving food to energy. And there's mitochondrial biogenesis, meaning actually producing more mitochondria in each cell as a result of the physical activity we demand. This is all driven by redox chemistry. There's a wonderful article in Experimental Physiology in 2009, volume 95, pages 1 through 9. It talks all about this, more than we can have time today to discuss. But leave it said, muscle cell adaptation requires redox chemistry to occur. And it's directed by the nucleus to repair and replace and help our muscles to change form in response to our activities. Maintaining an aerobic posture in our metabolism is critical in our performance. For this, I'll share an anecdote. Years ago, as I would train, being a physician, I have access to little gadgets and fun things. And I, yes, would carry along a little device that you can put on your finger that measures your oxygen saturation. And normally at sea level, where I was training in Kentucky in those days, I would wear this, and if I would go up and down hills, my oxygen saturation would vary from the 90s into the 80s. And as I try to make my way up a hill, my oxygen saturation would drop because of the demands that I was placing on my body, and I'm breathing harder, making my way up a hill. As I was able to supplement my body with redox molecules in a balanced formulation and continued my regular training, I was astonished by the fact I could not ever, on any of my regular hills, drop my oxygen saturation into the 80s. I would try. I'd try to run harder and faster, and I would literally run out of energy before I moved my body into an anaerobic environment. So what's the end result? If we can maintain aerobic metabolism, we are efficiently burning fuel aerobically we don't create metabolic wastes of lactic acid. When we burn fuel anaerobically, we create lactic acid. And so we know what that feels like, sore muscles after a really hard workout, because we've pushed ourselves past the limits of aerobic metabolism. So if anybody has a little oximeter they have access to, try my experiment. It's a lot of fun. The last thing is the movement of nutrients for muscles. Our muscles really demand a lot of calories, not quite as much as brain cells and heart cells, but a lot of energy goes there. It's the way we can affect our caloric requirements most of all. So as we try to burn fuel as a way of maintaining our weight and things like that, we use a lot of energy, and these nutrients have to get into the cell. The doorway to a cell is through the cell membrane, and those doorways are all driven by redox chemistry in terms of the ease of allowing nutrients in and waste products out. So without an ample supply, either provided by a cell or by supplementing our body with redox molecules, getting nutrients in and out is critical. It can mean the difference between your legs cramping up or not. And if you're trying to run a race and all of a sudden you're in your last mile and your legs cramp up, you're going to wish you had done something about maintaining a proper redox potential. It can mean the difference between finishing or not finishing if you totally cramp up. So I hope that's helped you understand some of the basics about athletic endurance, what we can do in terms of remodeling our muscles, maintaining an aerobic posture, and helping our nutrients move in and out of our cells to prevent cells from literally locking up in a cramp in our muscles. So thanks for attending this little conference on athletic endurance, and I welcome you to another video in the future.